To me, one of the most important things that enterprises can do is to think critically about where might a technology be today and where might we expect it to go in the future.
Welcome to the latest episode of Tech.Rulez.Period, today with a bit of a hoarse voice. However, my guest today says about herself that her purpose is to realize that everybody has a role to play of how we develop and design technology. She's the Vice President of Thought Leadership at Singularity University, a world-leading think tank on technology. Welcome to the show, Alix Rübsaam.
Thank you so much for having me.
Alix, thanks for being at the show. Tell us a bit about Singularity, because I don't think everybody knows about, what it is about, when it was founded, what the whole theme around it is. And then also maybe a bit about yourself and your role as a key thought leader at that institute.
Yeah, well, Singularity was founded in 2008 by Ray Kurzweil and Peter Diamandis. They came together to found a place where people can come to learn about how different technologies grouped together under the name of exponential technologies may impact our businesses, ourselves, and our world around us. And so they did that in a way to educate, to inspire, but really also to empower what we call future makers. So that can be leaders, that can be governments, that can be startups or entrepreneurs, to leverage technologies to address some of the biggest problems that we see in the world. And the specific technologies we talk about, we call exponential technologies because we approach those through the lens of how they develop along an exponential scale. If you think back of what Moore's law is this observation that the cost of processing decreases by half every, I think, 18 months now. And the computing power also doubles along that same line. And so that's what's exponential about the technologies. And that goes for a lot of the technologies that we see, be it AI, be it biotech, be it space technology. Space technology is actually one of my favorite exponential technologies because one of the exponential curves that we talk about at Singularity in space technology is that the cost of sending 1 kilogram of cargo into space has also decreased along an exponential curve. So grouping all of those technologies together and observing really how they develop, but then thinking about how people, anyone, can leverage those to address some of the world's biggest issues, be it climate change, be it hunger, be it education. So that's Singularity. I've been involved since 2015. I became involved originally as a student myself, and later as my research is in responsible AI, has been since 2014. And so I was asked to join Singularity's body of experts. And so there's around 300 experts that work with Singularity or are Singularity experts all over the world. And I used to be, I'm still one of them. But in addition to that, I am also now leading that department and sort of leading what we do in terms of our research, our expertise, and the knowledge broadly.
Okay, but tell us a bit more about how do you figure out whether a technology is an exponential technology or just a normal technology? I mean, and you described the logic of what defines an exponential technology, but how do you, you don't know it in the first place, right? Or do you?
Well, it turns out that a lot of technologies develop exponentially, basically because it's on, if it computes, right? If it uses processing power, then it adheres to Moore's law because that's about processing power. So if you think about the cost for, let's say, a virtual reality headset, right, is also contingent on the cost of computing power because it uses computing in order to be able to render an image in front of your face. Same with if you think about biotechnology, we approach a lot of biological processes now digitally, right? We have digital representations, and there's a great one of our 300 experts, Tiffany Vora, who talks about this approaching biology really as a technology because we're sort of looking at it through the lens of at the genetic level, right? Approaching that as you would code. and thinking about how you can sort of manipulate that and transform that into towards different goals. It turns out you also need computing power in order to be able to calculate how you can fold proteins. And so similarly, you come back to that notion of Moore's law, really underwriting all of these things that sort of have to do with computing. So it turns out that a lot of the things that you can talk about in terms of anything that rests on computing power is actually exponential. I think in addition to that, one of my favorite things is to ask across our body of 300 experts is to ask them, well, what's the exponential force behind whatever you're interested in? So if you think about data science, right? Actually, the cost of storing data, and we've all experienced this, right? It used to be insanely expensive to store a terabyte, and now it's just like the most, yeah, of course. And so we feel this sort of like decrease in cost and size often. I remember my first terabyte external hard drive was a brick.
Yeah.
And now it's just like a little. So we are more familiar with this exponential development of these technologies than we often think about. So data is one that goes into AI, right? Because being able to train a large language model with the amount of data that it needs would be prohibitively expensive if you tried to do that decades ago. You wouldn't even be able to do it because we hadn't digitized enough data. But the ability to store data, to train our AIs on data, that is itself also a computational process. So all of that has decreased in cost, and we're able to do more of it for the same amount of compute. And so that's really sort of like what lies at the foundation of that exponential development. And what's tricky about that is that, as we well noticed with COVID, is that we are not great at intuitively feeling the speed of exponential growth, right? We can sort of think linearly. If I go from 1 to 2 to 3, that kind of makes sense to me. But if I go from 1 to 2 to 4 to 8 to 16, it very quickly stops making sort of like gut sense. And that's where how we approach a lot of these technologies is through that understanding of, it's going to go very quick, and it's going to feel very sudden. I think if you think about the development of large language models, which was suddenly a year and a half ago, ChatGPT, all that. And we were all like, oh my gosh, where's this coming from? But if you look at how they were developing it, it's been since 2015. And it was just like this sort of like deceptive, what seemed to be low activity growth. But then once he sort of hit that critical threshold, it suddenly seemed like, oh my gosh, it's everywhere. And it's going so fast. And it's like, it's been going along that exponential line for quite a while. It's just that we're at that inflection point where it's suddenly exploding everywhere.
Okay. I mean, you describe it as a research, and you dedicate basically a lot of your daily work into either executive education or doing the thought leadership around those technologies. But what would you recommend an enterprise of how to best deal with this sort of exploring and understanding how these technology can make an impact on their individual business? Do you have any advice to executives on how to deal with that?
I think the first part is sort of to that, what I just called like that deceptive phase, is often when we get told like, oh, this is going to be a technology and it's going to be huge and it's going to be amazing and it's super hyped. And then we look at it and it's like, not that great. And it's kind of disappointing and it doesn't do what we want it to do. Keeping that exponential curve in mind is one of the most important things to think about. And my co-facilitator for one of our programs, Aaron Frank, says this really well. Whenever you see a technology, even if it's cutting edge, it's the worst it's ever going to be, right? Mm-hmm. Because if you understand that the computing power underneath is going to be cheaper and better from there on out, then considering that any generation that follows on to what might today be cutting edge is going to be better. And so he uses this example about, if you look at those old videos from the 90s about mobile telephony, right? And everyone was looking at these huge batteries with like a phone.
I remember them.
That you had to put in your car. And everyone was like, well, that kind of sucks. Of course I don't want it. But if you think about what that looks like today, then it's cheaper, relatively. It's much faster. It also can do a lot more. But even just on the pure basis of telephony, like just the access to that was the barrier to access was huge because it was expensive, it was clunky, it was kind of silly, and no one needed it. And so you see this force towards democratization and ubiquity where everyone started using it because that price point has dropped. So to me, one of the most important things that enterprises can do is to think critically about where might a technology be today and where might we expect it to go in the future. There's an entrepreneur that we work with at Singularity. Her name is Lala Win. And so what she's done is develop this education platform that uses augmented reality technologies. And she did that. She's from Myanmar. And so during the coup, there was no access to education. And so they were able to continue teaching kids because they could download onto their mobile phones the curriculum. And then they could look at it. And it's super interactive, right? It shows you, for one that she shows a lot, is like it shows you the heart, and you can like turn it around with your phone and zoom in and zoom out. And it's a super interactive curriculum. When she started building that, one, there wasn't enough computing capabilities on smartphones that they could support augmented reality. And two, there wasn't even enough smartphones in the hands of children. But she was the one, she sort of foresaw that both of those things would become cheaper and more available. And as such, she could anticipate a future where this product made sense. And she, to me, is the best example of someone who understands what underlies that sort of like exponentials and how it drives technologies forward in being able to anticipate. Now, I'm not saying we're all as genius as she is, right? But that perspective to me is one that I would recommend leaders to adopt, to think about. It's not so much about where things are today, but finding sort of what problem you're trying to solve, which is always easier said than done. And then thinking about how technology that may not be available today, but that might be available in the future, might be able to help you serve for that need.
And if you describe it like that, is it like a skill set that everybody in an organization needs to have? Or would you rather give the recommendation of starting with a center of excellence where you have specific people like yourself in a corporate environment that only dedicate the day-to-day activities into doing such work? Or is it rather something that you need to distribute in the entire organization?
I feel very strongly that this is something that this is something that everyone has a role to play in, because this whole notion of, okay, we have this exponential development, and this is from one of the co-founders of Singularity, Peter Diamandis. He develops this framework. It's called the 6Ds, where you go from that deceptive phase to sort of like a digitized and ultimately democratized route of that technology takes, which really means that because of the dropped price point and the increase in ability, it means that everyone gets to play with and direct technology and decide what we do with it. The girl I just mentioned, Lala, she's a teacher from Myanmar. She's not a coder. She's not, but I think the big, most important and most exciting thing about what these technologies allow us is the ability for all of us to play a role in shaping them, right? In deciding where to take them. And so segregating that away into a center of excellence, or by saying like, oh, you're not technical enough to do this, would, in my opinion, be a waste of opportunity. My background isn't in technology. My background is in philosophy. And I work on AI. I work in responsible AI from that perspective, because AI has become accessible enough that someone like myself without technical training can do things with it. And so the most important thing is to know what the problem is that you're trying to solve, and then what you need in terms of upskilling for the technologies that you might want to solve, you can get. That's easily done. That's the easy part now. So no, I feel very strongly that we all...
I get your point.
Yes.
So looking a bit more into your specific area of expertise or research, responsible AI, there is a lot of debate about the role that the EU plays versus the role that the US or Northern America plays. Well, what's your view, and maybe can you elaborate on how you look at the two sides of the continuum? Is it a continuum? That's also a big question.
Also a big question. Yeah, it's interesting because the timelines are so similar, right? When GDPR came out, the US was really sort of lagging behind. They had California was the first, they had a state law about data, but GDPR was a front runner. And now we see this place where both the EU and the US are developing legislation around AI safety at a very similar pace. So we can do much more comparing and contrasting. I think in both cases, it's still not exactly clear what either of the regulations mean and what they're going to mean in practice and what's going to show up at a compliance office as sort of like executable rules.
Mm-hmm.
What's interesting is how they came into existence. What the US has done and what the EU hasn't is they've invited quite explicitly and quite publicly tech companies to weigh in. So it's Google has helped them write that regulation, which Google will also tell you whenever they can, right? And so it's interesting to see. It will be interesting to see how that eventually shows up in regulation, because it's like if you ask me to regulate me, I'm going to have a different opinion about that than if I have some external body, asking them to regulate me. So it'll be interesting to see how that shows up in eventual regulation. I do think that what the US came out with last year, the last one from last year, you can tell they have people in that know what they're talking about. And the EU there's parts of it there where it's so vague to the point of like, yeah, that seems obvious. But I also don't know if it's sort of like, it felt more toothless in that sense. But neither of them is in a place where it's sort of like, oh, implement them today and we know exactly what that means, right? And here too, I think, because it deals with fairly nebulous concepts of like fairness and accountability, what I have seen is that people and organizations that I work with that handle financial instruments or are generally more exposed to dealing with heavily regulated instruments are probably at this point ahead for everyone else who hasn't, because there's where those nebulous concepts also show up in terms of like fairness. So I see there's a bit of a shift happening, that some of the organizations that everyone's anticipating these regulations, but some of the ones that are more used to dealing with heavily regulated instruments are the ones that are slightly better prepared. But now everyone is using AI, even organizations that have never dealt with this. So to me, it's at this point hard to tell the difference between the two, because it's still fairly high level, but there is a distinct difference in that the US has much more explicitly worked with Google and Microsoft and others. And I think that's what will show up as a marked difference between the two.
Okay. I mean, everybody is talking about AI and the impact it has. and you're saying everybody applies it on a day-to-day basis, in the newspaper, etc. It's your research field. How do organizations actually figure out whether there is, or how do they measure value? Because that's a question that my clients in my profession ask me a lot, because they say, okay, I've done this, but I don't really know whether the invest I'm putting in is actually getting me something back. So what's your experience around that?
Well, my experience is that everyone is foaming at the mouth to apply AI, and not everything is an AI problem. Like, I think that's that's why I say, like, people really need to think about what's the problem that you're actually trying to solve. And sometimes the solution isn't an AI solution. I think the comparable would be, say you're doing business in Europe, right? And you've got your clients there, and you're also getting your resources from there. And suddenly someone invents the airplane. And then you might run to your board and say, like, what's our airplane strategy? Because you just think that that's what everyone's doing. But if you're in Amsterdam and you're importing goods out of Utrecht, you do that by car because it's that close. If you then suddenly start sending an airplane to Utrecht, that's going to cost you more money than it needs to. It's not going to get you anything new or specific or better than you're already doing it, because it doesn't make sense for that particular problem. Now, if you were to say, actually, there's a lot of talent in the US that has something that we specifically don't have, then you might say, we need an airplane strategy to get those people here. But this is where I see a lot going wrong, is that organizations are just like, we need an AI strategy. We need to be applying AI. And it doesn't really make sense to say that unless you know exactly what it is you're trying to solve. In most cases, still today, even with ChatGPT, but this has been true for AI, is like, you really want to use AI for something that you do often, right? And something that's fairly repetitive, fairly sort of like predictable. before ChatGPT, this was even more true, right? If you were building your own model, then you're not doing that because you're doing something once. If you're doing something once, you just do the research for that one thing and you do it the one time. If you're doing something 10 times or 10 times a month, then you might think about like how much of this process is automatable. Then it starts making sense. And what you would see as a result is a decrease in cost, a decrease in time, a decrease in that's the kind of results that you would be expecting to see. Now, the flip side of that is that, of course, with these exponential technologies, you might not see that immediately, right? You might see like, okay, we know this level of compute is not here today, but we're expecting it in the future. So the first couple of months, we might not see that return on investment directly.
It's what you described before, right?
Exactly.
This moment where that hits.
Yeah. So there's that thing to be considerate about. But at the same time, if you're just automating for the sake of automating, then you actually run the risk of building blind spots into parts of your business that you should actually be keeping an eye on. Now, with large language models and with ChatGPT, with all of those generative AI, broadly speaking, I would say for anyone to just go and experiment with it. I have been in front of C-suites and boards, and I ask them, do you think like the people sort of like the entry-level workforce, do you think they're not looking at Gen AI, what they can be doing with it? And boardrooms full of people who've never even had a conversation with ChatGPT. And it's like, there's only one way really for you to figure out what you might do with it, because there is so much you could be doing with it that I think every day with Gen AI especially, new applications are born because new people with different problems are looking at what they might be able to do with it. But there too, if you have something that needs solving, then you might look at these technologies. If you don't, then if you're good as is, then there's no reason to sort of introduce a technology to your workforce in that way. Then it doesn't make sense to do it.
Makes a lot of sense.
I mean, it's,
Last question, more a societal question. I mean, I feel the dedication to the topic and the enthusiasm that you put into this. We know based on statistics that not that many females are interested in technologies. Do you have any, can you do an advertisement for more females looking into technology and that it is as fascinating as you describe? What's your view, and maybe what's your outreach to everybody that is watching us?
Well, this is an ongoing problem, right? Do you know what's fascinating about this? I do call that a problem. What's fascinating is that computer programmers used to be women. Almost exclusive, though. Yep. And it's funny because if you look at the origins of Moore's law, how much compute you bought with a specific for like $1 or whatever was actually expressed in human labor, female human labor. There is this trend, there's a name for it too, but I forget it now. There is this trend that once a specific job starts gaining prestige, it then becomes a male associated job. And so this is what happened with computing as well. It actually was promoted as like just simple maths that housewives could do. And so a lot of the actual first computers were humans and they were female, they were women. And so something happened where we started associating prestige with this job, and as such, it became suddenly a male-dominated field. Besides that, I think one of the most important, and we see this expressed in my field, specifically in responsible AI, because what we see is that because there is only such a small subset of people that are programming AIs, this is where my biggest pet peeve is really around the fact that people ascribe a very high level of objectivity to computer-generated results, right? We think computers it's just maths. It's only numbers, and it's never only numbers, right? It's always a selection of numbers that was made by a human, or a selection of data that a specific algorithm was trained on, and that selection was also made by someone. Because of the underrepresentation of women and people of color in these fields, we see that all these selections that are being made around what data sets computers are trained on, what language sets, they're all biased. We know they're all biased. And then suddenly we put them in computers and we think that the results that the computers generate are somehow not biased. I remember an example from just when the first sort of image generators were really hyped out on, I think on Reddit. There was this post of 6 image generating AIs. Do you remember in the beginning, they all had trouble like generating 5 fingers? It was either 2 or 3 or 7. And yeah. And so they had this comparative analysis of all 6 different image generating AIs generating hands to compare which one was better. And everyone in the comment had like their tribal association with one of them and was going well. But what no one commented on is it was 6 white male hands, right? They had various levels of fingers and accuracy in fingers, but none of them were anything but white and male. And that's such an expression of representation that is lacking in the field, in education around it, but even more so in just sort of who gets to make decisions around this. So in addition to that, I would say another big issue that we see, which isn't necessarily biased, but it's more about like how we scale these technologies, right? There is so much human perspective that we need in order to scale technologies like these. Well, to give an example, if I have a self-driving car that I'm training here on the streets of Amsterdam, right? And it's doing really well and it's not causing any accidents. But then I say, okay, now let's deploy it in New Delhi. Yeah. We would all say like, okay, let's do some additional training, right? Because we have a human perspective that we can say, okay, that self-driving car is going to operate in a context in which it wasn't trained. And so that's human perspective in the loop. That's really where I think that, and in the bias part, as well as in just what questions are we trying to address with these technologies, is where we need more equitable representation in order for these technologies to actually meet the needs that we have, right? And we can have technologies that really are very good at meeting the needs of affluent white men, but that's only a small part of everything that we have. And so if we want these technologies to actually work in the way that we want them to work and to solve the problems that we find important to be solved, then we need to all participate and push back on 6 images of varying levels of fingers, but all of them white male.
Thanks, Alix. Very, very insightful. I've learned another part of statistics now. Thanks a lot. Thanks for being with us today, and see you around.
Thank you so much for having me.